AB Calculus second 6 weeks test. This is fall 2015. The first set of 6 problems has to do with finding the derivative of a function. In problems 1 through 6, the function is given, find the first derivative of each function, 1 point each. Well, for this function, you have f of x, and this function is all ready to differentiate. We go ahead and write our answer as f prime of x equals, and the derivative of 2x is going to be, we have x to the first power, multiply that 1 out front, so we're going to have 2x to the 0 power, which is just 2, and the negative 3, the derivative of this constant, negative 3, is 0, so this is our answer boxed in. Problem 2, we have g of x equals 1/3 x cubed minus 3 over x squared. Well, to do this, I'm going to rewrite what I call calculus-friendly form. This first term here, 1/3 x cubed, that's just fine. But the second one, we have minus 3, and we have x squared in the denominator, which we make x to the negative 2 power, the numerator. So, finding g prime of x, we have 3, that's 3 out front, times 1/3 x, and x we have 3 minus 1 is going to be 2, so we have x squared. And then for this second one, we have this negative 2 power, x to the negative 2 power, so we're going to multiply by negative 2 out front, and then we have this 3 that we kept here, and we have x to the, this x to the negative 2 power, negative 2 minus 1 is negative 3, so we have negative 3, so we're going to clean it up and put our final answer here. G prime of x equals 3 divided by 1, 3 times 1/3 is 1, so we have x squared. And then in this next term, we have minus minus, which is positive, so we have plus, and 2 times 3 is 6, and this x to the negative 3rd power becomes x to the 3rd power, but in the denominator. So this will be our answer to problem 2. There's no partial credit on these. You get it all right, or you don't get any points on this. Okay, this next one here, we have a quotient of 2 functions. We have f of x, it's a little bigger. We have f of x equals 2x minus 3 over 2x plus 4. And since we have a quotient of 2 functions, we can use what we call a quotient rule. There's a different way of doing this, but this is probably the best way. What we have is the high part of the function, which I'm going to just label hi, is equal to 2x minus 3, and our derivative of our high, which I'll call d high, is 2. The low of this function is 2x, that's denominator, 2x plus 4, and the d low is 2. And so we can find the derivative by using what we call quotient rule, and that is the low, in this case, which is 2x plus 4 times the derivative of the high, which is 2, minus the high, and the high is going to be 2x minus 3 times the derivative of the low, which is 2, and we take all of this over low squared, which is going to be 2x plus 4. And so to do this low squared, we have to wrap that 2x plus 4 inside parentheses. And so now, really, it's just a matter of cleaning up our numerator. And so we we're gonna go ahead and distribute that, and again, whatever we have in the numerator, it's gonna be over quantity 2x plus 4 squared in the denominator. Okay, so we have the first thing, we have 2x times 2, which is 4x, and then 4 times 2, which is 8 plus 8, and then we have minus 4x, because 2 times 2x, so minus 4x, and then we have, in this case, minus 6, because we have negative 3 times 2, which is negative 6, but we have a minus out front, so negative, negative, we're going to have plus 6. And so what happens, we cancel what we can. We have 4x and minus 4x cancel each other. So we're left with f prime of x equals, in the numerator, all we have left is 8 plus 6, which is 14. And in the denominator, we have 22x plus 4 to the power of 2. And this will be our answer to problem number 3. All right, problem number 4. We have find the derivative of this function. I'll make it a little larger. And here, what we have is a situation where if we wanted to, we could expand this expression here, quantity x squared minus 3 to the 5th power, and just expand it out. But that's going to take a long time and leave a lot of opportunities for mistakes. So what we'll do is treat this thing here as a product of two functions, and the product of those two functions will be f of x equals 2x, which I'll call u, and g of x equals quantity x squared minus 3 to the 5th power, which I'll call v. And then we'll just go ahead and on the right kind of organize this, is that we call the u 2x, and the u prime we're going to call 2. The v we're going to call quantity x squared minus 3 to the 5th power, and the v prime is going to take a little work. We're going to have this 5 out front, because we take the power of 5. We have x squared minus 3 to the 5 minus 1, or 4th power, times the derivative of this inside, which is going to be 2x. And so just simplifying this out, v prime is going to be 10x times quantity x squared minus 3 to the power of 4. So writing out f prime of x, we write out f prime of x as u v prime, and u is 2x, and v prime is going to be 10x. Well, yeah, I'll say, let me just put like 10x times quantity x squared minus 3 to the 4th power, and then it's going to be plus v u prime, and v is going to be x squared minus 3 to the 5th power, and u prime is 2. And so simplifying all this out, we're going to have f prime of x is equal to 2x times 10x is going to be 20x squared, and then that's going to be times quantity x squared minus 3 to the 4th power, plus, we're going to put plus 2 There's 2 up front. Quantity x squared minus 3 to the 5th power. Now this seems like it might be a little involved, but depend on it when I tell you that this is a lot better than if you'd expanded out and done all this individually. Next problem, 5, we have find the derivative of this one, which is h of x equals 2 times the square root of quantity 3x minus 2. For this, we're going to rewrite this as h of x equals 2 times this radical 3x minus 2 is to the 1/2 power, which is the square root. So h prime of x is equal to this 1/2 times 2, and we have 3x minus 2 to the 1/2 minus 1. Well, 1/2 minus 2/2 is going to be the negative 1/2 power. And so now there is one other thing, which is the derivative of the inside. The derivative of 3x minus 2 is 3. So in simplifying and writing our answer, we have 1/2 of 2 cancel each other. So we have h prime of x is equal to, we have 3 in the numerator, and this 3x minus 2 to the negative 1/2 power is just going to be the square root of 3x minus 2 in the denominator. And I'd like more people to get in the habit of boxing in their answers. I don't see a lot of boxed in answers. I'm seeing illegible writing in many cases. Okay. Last one in this set, we have f of x equals the 4th root of 3x. So for this, I'm going to make a rewrite of f of x equals 3x, and this radical, the 4th root, is to the 1/4 power. So f prime of x is, we take this 1/4 out front and times 3x, and we have 1/4 minus 1, which is going to be 1/4 minus 4/4, which is going to be negative 3/4. So we have to the negative 3/4 power up here as an exponent, and then rewriting this is going to be f prime of x is equal to, and then there's another thing. We have the derivative of the inside, which is 3. There we go. So just wrapping up, we have this derivative of the inside, which is 3 over 4, and we have this 3x to the negative 3/4. So that's going to be, it's going to be a 4th root here of 3x to the power of 3. So this is going to be just kind of making it a little more legible. I'm going to bring this 4 down here beside the square root thing. That's, there we go. So that's what it looks like. These first 6 problems, they should be commonplace. It should be easy to get those 100% right. There shouldn't be any problem at all on those things. So that's going to be the first part of this test. And I'm going to give you the rest of that later. Thanks.